Hello, what's going on? This is Jurjan, and we're back doing some Purescript. So let's get right to it. Okay, so last time we were looking at how to include side effects into our code in a principled way, and yeah, that led me to sort of go off in a kind of tangent, I suppose, around um, application architecture and whether we could borrow from the three-layer cake idea from Haskell, what that would mean in terms of doing it with Purescript React Explore with this comonetic flavor. And to be honest, I'm not sure we are close to resolution around what to do there. So let's try to go towards that. At least try to find like a next practical step that will help us to test this theories here. Some of them are in principle not revolutionary like the three-layer cake, but apply to a comonetic setup context, then that might be a little bit more tricky. But it could be, I think one of the things that emerged is that it could be that layer 1 and 2 are actually monadic, and then we switch to comonads somewhere along the way. Uh, and also, I'm not so sure that at this point um, it's a huge gain to do comonads, but there's a few things to prove, I suppose. So maybe um, I can do a new to do for today. Actually, that's probably not how I should do it. I should copy something for today, the 6th, and take note here. Okay, and specifically just adding this new section. Okay, so so let's put high-level goals here. We want to have a manageable next step here. And we don't exactly know what that is. But we also want to check our assumptions. And one of the assumptions is that comonads are useful higher up the cakes, higher up the layers. So a third or even 2.5 or something. So how would we know that? One of the ideas that maybe decompose while monads don't. So that sounds fairly compelling, but in the three-layer cake idea, it's just functions. But layer 3 could be just functions, no? So let's check this a little bit. I think I had Thomas Honeyman's blog here, and say pure business logic should be effect free. So there's something about definition here, because for instance, the state monad, is that an effect? I think usually, yeah, there's two ways to consider that. There's a more mathy way in which even something like that is an effect. Even I think like even changing, mutating it, or even returning a changed data structure can be seen as being an effect. But something like the state monad, is that always an effect? I think that also depends on the definition. So um, Yeah. So when we say effect free here, here it says use pure functions and simple data types to implement business logic. Yeah. And that's the capability, but there's no real examples of actually using layer 3 in this. Let's look at, yes, the original specification. So layer 3, business logic, Gene streaming, you can create pure conduit of pipe. Okay, all the effectful data should have been acquired beforehand, and all effectful post-processing should be handled afterwards. But you more goes into detail how to use it. You need streaming, you can implement pure conduit of pipes with type signature like this. Right, so no effect in there. The right with, well, I mean, no effects in there except for the monad here, I suppose. Or is that a transformer of sorts? In that case, the conduit IO, even if it's parameterized by an M, is pure. Okay, let's look at Haskell conduit rapidly. It's not probably going to be super rapid because it's not super trivial. Conduit T takes is the one that has an M, and conduit, where is conduit without the T? There's a conduit TIOM, source, R is the rest. So I think, yeah, oh no, it's a final result, so it's not the rest. Conduit IMO equal conduit TIMO unit. Okay, so that returns unit, but so in that case, what is M? M performs actions in the M monad. So that does feel like a transformer to me. Conduit IMO, conduit IMO M. That's deprecated apparently. Consumes a stream of input value, produces a stream of output values without producing the final result, but there's still an M. So I'm not sure how that qualifies as pure, but maybe that's what I'm saying is like it's not because there's a monad that is not pure. In fact, monads are pure. So really here it's mostly about effectful data. That's things that yield data coming from the outside world, and so it's really effects more in the computer in the software engineering sense rather than more the computer science or math sense. So that makes sense, I think. So it says, yeah, no IO. Could be just functions, but in practice, they're likely to have monads in them. Expresses no dependency on where the data comes from nor on how the output is handled. Right, so this M is completely disconnected from anything in IO. It can be pure state, but although it's probably, I'm not sure you want that, but I'm sure you could if you wanted like a counter or something that's not effectful, then transient state could be a state monad M in there. If the result of computation is to perform an effect, then it's useful to encode that effect as a data type. Right. Free monads encode computation data type, but they're very complicated. You can usually get away with a much simpler data type to export the behavior you want. Simple non-recursive sum type command suffices an interface between a pure function and an effectful one. A list of commands adds a lot of flexibility without dramatically complicating things. That's cool. I mean, I think I am dramatically complicated things. We can know that. Oh, that's cool. It's been expanded a bit. Meaning it's actually kind of ping backing the Purescript halogen. Maybe I should also take a quick look at this. Capability, API. I think this is very well annotated. Right, so we have some, yeah, but it's halogen. So how, I mean, I suppose, is halogen then seen as being the pure thing? AppM. Yeah, AppM, I think, is the reader T bottom layer. Is that right? It's called apt in here. And it's a reader T stuff. Is that similar here? In this case, it's store T. And it's mono transformer has the ability to have a central state. Okay, I see. So that's just a specificity of halogen. And it has an effect monad, which is the M. And so it's realized. That's all good. Let's remove that one. Right, so the log messages, that's what we have in this example. And yeah, so I'm not sure where components fit in that picture, to be honest. We have the capability like log messages. So yeah, let's take a quick look. Basically, in theory, so log messages is not going to be of interest to us. Yeah, we don't want the pure functions to call M, right? To call log, because if they call log, it means that they are effectful. So the so what's an example of using, like, the fact that it uses conduit is, well, it's interesting because because I am trying to bridge things between a little bit more of a pipe machine conduit perfunctor Purescript run streaming world and a more component driven world like tree of component React world. So how would that work? Here, use pure functions for data types. So if you get the effect out of this layer, we get to use classic functional programming techniques and principles. The following section will implement conduit according to this architecture. Ah, okay, so actually you are using conduit. Oh, no, hold on. Conduit, I think, is the name of his application. Just to make things a little bit more confusing. Data and pure functions. Customer orders. Do we have any of this stuff in the halogen order? Endpoint, order validation. Yeah. Let's, since this is so extensively commented pure functions, API request for validation. Maybe we say pure function. This function was main, dialog header validation forward button. Export was the pure HTML function. Aha. I wonder if you can use any function that relies on the effect monad. I wonder if he considers that components are pure because they take they take some input and they return some HTML. Oh, that's not what I want to do. Pure. Okay. We need to write simple pure validators. That seems to be something to interface with this formless library, so it's not going to be very relevant. Capability now. A capability represents the ability to fetch the current time. This is pure, so we can use fixed time in a test manner for determinism. Data avatars, tag input. So here, I suppose you do have users. Principles for designing data. Let's go take a look at the bottom. A tag for remote data. Lifecycle type. Keep a data pure and stateless as much as possible, but sometimes we need to present data in one of many states. We may need to write functions to transition from one state to another. We can keep our pure by writing types that capture the possible state of our data. For example, most of the time conduit is needed from the server. We're constantly going to have pages which may not have fetched some necessary data yet. Okay. So that's obviously more of an operational concern rather than business logic per se, but I suppose you can pretend that it's sort of, I mean, I suppose you can see that as business logic, actually. Okay. I had a side thought. A couple. I want to have some example. Find some use cases where this approach would be useful. So I think that means, yeah, I'm going to just maybe say that maybe data flow here or queries, but that's a bit of a rabbit hole. So I suppose an easier way would just be components, and so they list some this way to compose things. And if it pays out just with components, then maybe there's an argument to try things with harder things. Try it with harder things. Yeah, another one that's hard is, I suppose, where was it? I think it's a little bit confounded with data flow programming, but I think there is maybe strings actually. I think it's basically it's data flow. Right, there's this notion of spaces. which might be useful maybe for layout, but that's not clear at this point. Spaces as in matrices and things of this shape, meaning actually things like cursors, which is an extension, but a simpler extension of a query, really. And it's basically the store comonad. So that could be something manageable, right? Because we know the comonad. We could potentially then stack it um, or day it. So and try those two patterns maybe. Okay. And yeah, I think streams, queries, and spaces maybe are hard, and maybe data flow is harder, maybe. Okay. So let's pop back the stack, go back to identifying what we mean by pure in this three-layer cake context. And yeah, it seems like if all things are meant to be pure, I suppose that it's fairly operational. Okay, so let's see whether we have profile things in this code and take a look. Yeah, we have data profile, which yeah, seems like their username bio image, and oh, there's a rep type. Username bio and avatar, and that's profile, and then profile with email, profile with passport. So some kind of common denominator extended with other types and a relation type, which is very interesting. And then a way to then encode and decode all these variations. And then what? Then I suppose the question is, how is that used? Where are the functions? So there's an mk email, but that's just constructor and in the token field. Okay, that's the rep. It's been renamed. Revising the types. User, username and token. Okay, follow. Follow is a user. We need both the user to follow and the token of the currently authenticated user. We can just use the token directly because it's only accessible via the auth user type. Later we'll examine ways to make even this a pure function. Okay, so let's see. Follow seems to be the thing we might want to check. And there's a follow button. View article, capability, follow user. Takes a username. The ability to manage users in our system. Because logging in, registering, following, unfollowing, fetching articles, user, and more. This capability lets us ignore the mechanics of managing a resource and focus on our business logic. So with this terminology, do you have I thought that with the effects to the edge, it meant that capabilities were mostly a lower level thing. But apparently they're not. how do capabilities relate to the three-layer cake? So let's look at the list of capabilities. So we have the login one. We have now, which is a time-based one. Navigate is the router one, and then resource. So can we infer that those resource ones are actually the pure ones? The follow user takes a username and returns a maybe author. Ah, right, an author being a user, I think, of the system. So it must be a slightly stripped down data type compared to user. It's not in here. What's an author then? Page profile, data profile, type author. So it's the profile. It's a profile with a relation. We can update the profile. That makes a profile for the field used for authentication. Okay, not sure we care so much about that. But suppose we want to see an implementation of that. But okay, this instance lets us avoid having to lift. Right, okay. But that's to use this capability inside a halogen component. But where is it implemented? In appm. First, resource class describe write operation. Okay, resource class. Resource management. Capabilities module. We wrote some abstract high-level interfaces with business logic that tend to be highly effectful, like resource management and logging. We wrote interface just the types, no actual implementations, that we could write the same code once and swap in different implementation as we see fit. It's carried to mean benefit. First, it helps abstract away the implementation, so we focus on logic. Businesses care about reading, writing, and deleting resources, not whether it's done on the file system over RPC, blah, blah, blah. So this is basically CRUD, right? But this implements exactly how the CRUD is going to occur. And it's actually using something, it's plugged into the appm. So follow user makes an authenticated request to an endpoint. And then returns whatever JSON's been gotten as a response. This may be JSON, and puts it into a profile. the idea, I suppose, is that there's some composition going on. Because we use appm, we have access to these lower level methods like mk auth request. From the app utils, API utils. Yeah, but that's the backend basically, right? So all the resources basically call the backend to get the info. So does this? I hadn't realized this, that this needs some kind of backend. Is there maybe a mock backend that's part of stuff in the build? Building and running. Run local server. npm run serve. npm run serve just runs HTTP server dist. Backend server. Okay, let's look at the API. Finds that point data type. Oh, okay, so is that then a node application that actually, yeah, it looks like it actually. So I think, yeah, so this is both the backend and the front end, I think. DCE output, I don't know what that's supposed to be. So development mode, text dev. Right, let's take a look at main. And an out and half. So no, that's supposed to be in the browser then. And the main's in the browser. Ah, there we go. This guy is the API. So there must be a backend somewhere else. Oh, only 13 repository though. Portal. Oh, attribute crossing, just great. Really, that's nice. Global state management for Hamilton. Routing, data. Content store. Default request. Let's look at the intro. What are we building? Social blogging, level product, single page app. And I'll take a small break. All right, and I'm back. So we're trying to understand whether this is supposed to come with a backend already. Detail spec, hosted version, it's got a thoughtful API spec. Ah, that's it. That's the real world thing, and there's a complete API available. Okay, so that's understood. Um, and popping back the stack a bit more here. What are we looking at? We saw, okay, that has nothing to do with anything. Trying to understand, okay, 3-layer cake and Purescript, script real world. And let's just take this example, the follow user example. We have a component, for instance, like a button in a component calls follow user, right? And then follow user the follow user interface capability is what we call it, is declared here in a resource capability. Well, that's really the interface. And it's made available in the halogen monad. So, and then it's, and then the follow user capability is implemented in the main, in app_m right here. So what does that mean for our cake? Reality pattern, I suppose that's here, right? That's layer 1. App_m is the reality pattern, just as far as I understand. Let's double check. App_m. Yeah, it's that store, and you run it, and that's pretty interesting, actually. Because that's not unlike what I was looking at with this idea of like where does the interface between the component system and the effectful system and the maybe pure data structure, where does that happen? And yeah, I was thinking it's at the end of the world, and that's pretty close to the end of the world right there. And similar to doing it in an event loop, because here I think the reduce is probably what's actually doing the equivalent of Purescript Explore, of the Purescript React explore function, which is the kind of time ticking thing. So the fact that run app_m does this guide us to defining what that next step will be? think it will have to have some form of, like at the top level, we might want to run appm. The thing is, okay, the first manageable step maybe is not to implement the whole 3-layer cake. Maybe to just start with what we have and implement whatever is minimal, because this whole follow user thing, that is useful, but might be a slight distraction here compared to how we want our monadic layer to plug into our comonadic layer. I mean, sure, that is a way in which monadic layer might be decoupled. But like maybe we're focusing on the wrong problem. Okay. Is the 3-layer cake the right thing to focus on, the right pattern to focus on? Especially for the manageable next step. So maybe instead we want to focus on one will be, that's a noisy brain. Want to focus on like the monadic, like effectful monadic layer. So the interface between one, the effectful monadic layer, and two, the comonadic, like a pure comonadic layer. So it's like a 2-layer cake. And I think then that means the kind of the event loop or explorer or whatever we need to make it tick. So if that's the case, do we want to, so we do have like this counter example, right? So what if we plugged it into, so we could, for instance, use the counter example, like not the counter example, but the counter example. And wire the counter to a clock tick. So that would be input, and then maybe we and persists it to the console actually, and output to the console. That would be, if we start with that, we can maybe make it more manageable and more legible before we start adding a lot of things to it. So I think that's really good actually. I think I completed my having a manageable first step, and so then we just need to indeed provide this interface. So let's see what it's going to look like. Let's go back to our code, and let's go back to actually just focusing on the counter. So we'll simply comment all this and see whether things just rebuild. It seems like they do. And then That's not what we want. Where is, there we go. And there we go. We have a counter, and I think it reacts to me clicking on the key up, basically. Okay, so that's good. So right, so one thing we have here is this way to wire this external event key up to, like, as a hook, right? And we say this is coupled to the component tree, and it's a Reactism, right? But it's a UIism, I suppose. It's like it's just mostly you want, generally you have locality between your event handlers and the UI component that they focus on. So that's okay, but then what happens if we have some kind of clock, and then, so if we have some kind of clock, then probably we create it outside, and then we just wire this as an event. So let's look at Purescript event. Which unfortunately does. Why is it? Hold on, it's. I had not realized that it was archived. Okay, maybe there is another Purescript event in GitHub. Not really. But I thought that Halogen used Purescript events. Let's go check out Halogen and Spago. Doesn't use events visibly here. Is it web events that somehow have been ported to regular events? Because that is going to be part of the ones that would be wanting, probably. Do we use it? Does this use FRP event? Well, in a guide, that's not very. Use halogen subscription of FRP event in guide 05. That's merged. Oh, okay, I see. Well, that's strange. So they moved back and forth between FRP event and then back to something they called subscriptions. Yeah, already archived. So the package does not exist. Halogen subscriptions. The committee we're doing this intelligence 6 as well. Okay, that's a bit sad. So actually, FRP event is not what's been chosen in the end. Yeah. That's going to be too much, right? Event like. I don't know what made me think that simplification to event handler and event sources. use event RP. Yeah. So no, I had not dreamt it. It was meant to be used that way, but apparently they backtracked. Yeah, but I don't know if we should be shy about this. Maybe it's just that 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 Phil Freeman doesn't want to maintain this, but it really doesn't mean that it's not useful and doesn't work. What I'm curious about, oh, something there. Is it actually Thomas Honeyman who wrote most of that stuff? Oh, wow, yeah. Huh, amazing. Um, yeah, so there's been some backtracking on events there. Okay. Um, event handler types. Maybe action. Yeah, this is very halogen and event sources. Implemented the event from the event library. Set the origin event sources implemented on top of core routines. Simplifies the library internals, connect halogen with the more widely used FRP library. Turns out that that's indeed not the case. It's effective and subscribe, blah blah. So let's take a look at Purescript event and some of the existing event type in there. There's the time one, which we want. And then maybe in behavior, or the idea is that we could implement a console one. This time uses effect timer. So yeah, I think this is close to what we want. I think. So let's go back to using something nobody else uses anymore. And let's make sure that we have events. We don't. We have coroutines. Interesting. Um, and Spago install. Ah, right. It's not going to work. So we need to just fetch it. It might already be fetched. It is not. So let's fetch it. And it is path, split event. And what do we need for this? We need prelude, which we don't need to put in there. Console is there. Effect, filterable, mutable, unsafe reference, which might not be available. Let's see, JS timers and now. And maybe we do need prelude. Okay. And now we can install events. Package set, and it's called, is it event or event? It's event. And oh, version 6, yeah, that's not going to exist. We want version 130. And that's done apparently. Very good. So let's import that. Maybe we use these examples to guide us a bit here, right? We import FRP event as event, and then we somewhere, where do we do this? It's not clear. We, instead of subscribing, in main, instead of subscribe, we do gift effect blah, which I suppose is pretty cool. That's that's the subscription mechanism that we want. Let's make it pretty here. Event subscribe. What's IO there? Some kind of, I see messages. IO.messages. What is that? When running the root component, you also need to replace the use of coroutines. IO.subscribe consumer. IO.messages. I think that must be a way to hook. What is event.subscribe? Probably here. Subscribe. Callback. It takes an event. So IO messages are events. So, so maybe that's the way in which right, I think the halogen code defines messages as an event source, and then but then I'm a bit confused about the event source here. This is, I think, something akin to tying the knot, but it's not clear what that's going to look like for us. So maybe we try with this first, which is, I think, what you're supposed to do inside a component. But I remember trying to do that in in our earlier version, in fact, right? I think we had something like that. Top main. Yeah, here, push. That was, we're using attach from DOM, from the DOM actually. Do we have attach here? We don't use attach here. But that was giving us an FRP event. I think that's because Purescript DOM was doing that for us. Let's just double check that attach. Oh, it's not clear. It wasn't qualified. Yeah, I think it came from DOM. But that was, yeah, I tried to do this at the root actually. So maybe I can try and do something similar. It's just that we create this event and then we subscribe. And then we push something. That's a bit strange actually, this code. If we subscribe, H subscribe, I see. Yeah. So that must be a utility function to somehow wire the events. We're going to need something a little bit like that. So we have a couple of ways to go here. So one of these is going to be using FRP event. Including the FRP timers. And I suppose before I implement my own, I could just simply try and hook the timer in. Maybe that would be something more efficient. Can I try to do that? Like do it a bit ad hoc and then we can improve. Um, interval, right. So it's interval. So and it is the model FRP event time. Let's try that. FRP event as event. Import FRP dot event dot time, and let's import interval, and that's that is something ideally we want there, but it's not clear. We don't want it to do it on key up. We want to do it on component initialization, basically, right? So maybe here. So what we do just subscribe to an event, the interval 1000, I believe. 1 second. Okay, all good. Let's try again. And boom. So I'm subscribing and then taking something that takes an A, which will be an int, which will be the time, and returns an effect. And in that effect, I think, oh, well, we don't need to push. Yeah, in that effect, we'd want to possibly increment the counter. But obviously, we can't do this here. So we can probably do it here. Let's try that. Time, and then we do what? We do um, tuple URI interpreter. We want to send. Okay. So maybe I have to do it in UI actually. So hold on, maybe this is not still not the place. Maybe this is. It's probably not going to be in the right monad here. But here in theory, I do something like increment, right? And then it will be done. But it would be event.subscribe. Are you telling me this compiles? And really? I mean, it does compile, but doesn't increment the counter. pure unit. Then subscribe, blah. Do I need to return something specific? Maybe, I mean, I think this is also on keyup is also taking something that returns effect unit. Um, right. This in itself is, so I need to somehow um, execute this, no? Um, yeah, basically, I think I need to do this. That fails to build. Okay, so mode H, what? Uh, no 196. Yeah, of course. This whole thing is wrong. And so now, okay, now there's some trouble here. And how about here? Yeah, this is some trouble because we're not in the right mona, right? Yeah. So we want to maybe lift this stuff. Can we do that? How are we going to do that? Monad effect, effect. Yeah, so that doesn't work. But we need to do some type things, and I suppose that's what we'll do next time because I've been going for more than an hour now. So next time we'll just fix that type error, and hopefully that means that we'll have the first part of our simple example done, since we want to wire the counter to the clock tick, and then next we'll do FRP event for a console log, right? So that we have both the input and output. All right. And then we'll try and see how we can refactor things to maybe be more principled in how we deal with that, and see how close that gets us to something that's a little bit more streamy, I suppose, in its approach, and then see if it still makes sense to connect this more to components and how we deal with data flow in that case. All right, that's it for me. Thanks a lot for watching, and see you on Saturday. Although Saturday I might be traveling, so maybe Sunday. Bye bye.